Hey guys, this is a video on section 14.3, which is partial derivatives. Uh, Partial derivatives are a lot like the other kind of derivatives, the regular derivatives that you learned in Calculus 1 and Calculus 2. It's just with partial derivatives, partial means you keep all the other variables constant and you're only taking the derivative with respect to one variable. Okay, so you take the derivative with respect to one variable, okay, with respect to one variable, okay, and all other variables are constant. Okay, so all other variables are treated as constants. Okay, so you're taking the derivative with respect to one variable, and any other letter, any other variable that you see is going to be treated as a constant. And remember, the derivative of a constant is 0. And if you have a constant times a variable, the constant just stays there. So even though it sounds complicated, most people find partial derivatives to not be that bad once they get used to them, because most of the extra variables there are just going to be treated as constants. So you're really only taking the derivative with respect to x or with respect to y, but just one variable. So it's a lot like Calculus 1, actually, in that respect. Okay, so let's see some examples. I want to do lots of examples of this because it is a challenging concept, but mostly because there's so many different cases. But once you get used to it, it's actually not that bad. Okay, so example. Find partial f, partial x, and partial f, partial y. Okay, so find partial f, partial x, and partial f, partial y. So the way I'm saying it is one way of saying partial derivatives. So you can either say partial f, partial x, or you can say, some people say del f, del x, and they call it del because that little thing that looks kind of like a D, but not exactly a D. I believe it's a Greek letter called del, and that's the same as the partial derivative. Okay? And what it means is you take your function and you treat all the other variables as constants, and you just take the derivative with respect to x. Okay? And for this example, the function that they give us is a function of multiple variables, so it's f of x comma y is our function, and this equals x to the fourth minus 2xy plus 8y squared. Okay, x to the fourth minus 2xy plus 8y squared. And we want to find partial f, partial x for starters, and then we're going to find partial f, partial y. So starting with partial f, partial x, basically all we're doing is we're treating any other variable as a constant. So here, for partial f, partial x, or del f, del x, because it's with respect to x, we treat y as a constant. And if there were other variables like z, we would also treat those as constants. But here there's only two variables. So whatever other variables you have, besides the one that you're taking the derivative with respect to, those other variables are all treated as constants. So here, partial f partial x means we treat y as a constant and we just take the derivative with respect to x. So looking at this function, we know that the derivative of x to the fourth is going to be, if we bring the 4 out front and decrease the exponent by 1, we're going to get 4x cubed. Okay, and x is not a constant. That's why we're taking the derivative of that one. But then for the next term, y is a constant. Okay, y is a constant. So the negative 2 and the y, those are both constants. And also the 8y squared, that's also a constant. Okay, so all that is all those are constants. So it's a little bit strange, but basically the only thing we're going to be taking the derivative of is the x there. And we know that the derivative of x is 1, okay? But we still have the negative 2y left over. So we're actually going to have a minus 2y because the minus 2y is constant, and we got rid of the x because the derivative of x is 1. Alright, so we're just left with the negative 2y there. But then with the last term, the 8y squared, because y is a constant, that means 8y squared is also a constant. So this whole term is a constant, and the derivative of a constant is 0. So that 8y squared actually just goes away. So partial f partial x is what we have written here. Okay? Because that 8y squared is just a bunch of constants, and the derivative of a constant is 0. So that just went away. Okay, and now we're going to do the same thing, but we're going to find partial f partial y, or del f del y. Okay, and to find del f del y, we're now going to treat the other variable as a constant. Okay, so let's find del f del y. So any other variable besides y is a constant. So here x is a constant. Okay, we treat x as a constant because we're taking the derivative with respect to y. Okay, so that means this first term here, x to the fourth, because that's a constant raised to a power is still a constant, this first term is just going to go away. That's going to become 0. The derivative of any constant is 0. Okay, and then for the second term, let me erase some of this stuff. All right, let me just erase all that so that we can have a new setup here. So we had a minus 2xy and plus 8y squared. Okay, so anyway, what I was saying is now x is a constant. Okay, so the negative 2x there, that's a constant. Alright, so for our second term, we just treat negative 2x as a constant, and we take the derivative with respect to y. Okay, so that y goes away, the derivative of y is 1, so we're going to be left with negative 2x. Okay, so the x to the fourth just went away because x to the fourth is constant, because x is a constant, and the derivative of a constant is 0. And then for the second term, the negative 2x was constant, so the y went away, and we're left with negative 2x. And then for the last term, for 8y squared, we're taking the derivative with respect to y. So we're going to go ahead and use the power rule there. So the square comes out front, so we bring the 2 out front, and we decrease the exponent by 1. So we get 8 times 2 is 16y. So that gives us negative 2x plus 16y. And that right there is our partial f, partial y, or del f, del y. Okay, so hopefully that makes sense. That is a relatively easy problem, but you know, most of these are not too bad once you get used to them. It's a lot of the stuff that you learn from Calculus 1. It's just got that extra component where you're dealing with making different variables be constants. Okay, so I wanted to do quite a few more examples. That was example number 1. Okay, so, well, actually, I'm not going to call it example number 1. I'm just going to rewrite a new example. Okay, so here's a new example. Find del f, del x, and del f, del y. Okay, and for this one, our function f of x comma y is equal to the quantity 3x minus 9y quantity cubed. Okay, the quantity 3x minus 9y quantity cubed. So just like the last problem, if you're taking del f, del x, that means that your other variables are constant. So let's start with del f, del x, or partial f, partial x. So your other variable y is going to be treated as a constant here. Okay, so y is constant. And we just take the derivative with respect to x. But this one's a little bit trickier because we have a composite function. So remember, when you're taking the derivative of a composite function, you have to use the chain rule. So the chain rule says you take the derivative of the outer function, inner left alone, and you multiply that times the derivative of the inner function. So let's start with the outer function. So taking the derivative of the outer function, we bring the 3 out front and decrease the exponent by 1. Okay, so we're going to have 3 times the quantity 3x minus 9y, quantity to the second power. So what we did there is we're doing the chain rule, and we took the derivative of the outer function, inner left alone. And now we multiply this times the derivative of the inner function. So for the derivative of the inner function, since y is constant, that's going to mean the negative 9y is constant. So the only thing that we're going to have here is the derivative of 3x. And the derivative of 3x is just 3. Because this negative 9y is constant, the derivative of negative 9y is 0. Okay? And then the derivative of 3x with respect to x is 3. Okay? So we have 3 times the quantity 3x minus 9y, quantity squared times 3. So we use the chain rule. And then of course we can simplify this a little bit. So what we can do is we can just multiply these 3's together. Okay, so 3 times 3 is 9. So we actually get partial f, partial x equals 9 times the quantity 3x minus 9y quantity squared. Okay, and that's how they want you to leave your answer. Okay, so there's partial f, partial x. And then the next thing we need to find is partial f, partial y. So for partial f, partial y, the other variable is going to be constant. So in this case, since the only other variable is x, that means x is constant. X is treated as a constant. Okay? So once again, we're going to have to use the chain rule. And remember, with the chain rule, you take the derivative of the outer function, inner function left alone, and then you multiply that times the derivative of the inner function. So here the outer function is the cube power. So we're going to once again bring the 3 out front and decrease the exponent by 1. So we're going to have 3 times a quantity 3x minus 9y quantity squared. So that was the derivative of the outer function using the power rule. And then we multiply this times the derivative of the inner function. But remember, this time x is constant. So that means our 3x is going to be constant. So that's the derivative of 3x is 0. And then the derivative of negative 9y is going to be negative 9. Okay? So we're going to multiply this times negative 9. So you have 3 times the quantity 3x minus 9y quantity squared times negative 9. And of course we can multiply the negative 9 times a positive 3, and that gives us negative 27. Okay, so our partial f partial y is going to equal negative 27 times the quantity 3x minus 9y quantity squared. Okay. That's our partial f partial y. So you're going to have to review your Calculus 1 if you don't remember all these things like the chain rule, etc. Chain rule, product rule, and all that. But I'm going to try to do at least one example of each type of problem. So hopefully that'll help with your review of Calculus 1. But these problems really are just Calculus 1 problems, only you got the extra component that you have multiple variables. But you treat all the other variables as constants. So it's not so bad. Alright, cool. So let's go ahead and do another example. Okay, new example. Find del f del x and del f del y. So same instructions, but we have a new function here. So for this one, our function is f of x comma y equals the square root of 4x squared plus y squared. The square root of 4x squared plus y squared. So this is a bit more complicated looking function. But once again, it's a composite function, which means there's an outer function and then an inner function. So we're going to be using the chain rule once again. So let's start with partial f, partial x. Okay, so for partial f, partial x, remember all the other variables are constant. So here the other variable is y, so y is constant. All right, and then for partial f, partial x, we have this composite function. And if you want to make it easier on yourself, instead of writing it as a square root, you could write it as a 1/2 power, just to make it easier to apply the power rule. So we can rewrite this as parentheses 4x squared plus y squared, parentheses to the 1/2 power. Because remember, the 1/2 power is the same as the square root. Okay, it means the same thing. Alright, and then we can go ahead and do the chain rule and the power rule. So taking the derivative of the outer function, the 1/2 power, we can go ahead and bring the 1/2 out front and decrease it by 1. So that's going to give us 1/2 times the quantity 4x squared plus y squared quantity to the negative 1/2. So all we're doing there is we're doing the chain rule, so we're doing the outside function first, and we're taking the derivative. So using the power rule, we bring the power out front and we decrease it by 1. So 1/2 minus 1 is negative 1/2. Okay, and then we're going to multiply this times the derivative of the inner function. So here the inner function is 4x squared plus y squared and y is constant. Okay, so the y squared is going to be constant. So really all we're taking the derivative of here is the 4x squared. Okay, and there we're going to be using the power rule. So we bring the 2 out front and decrease the exponent by 1. So this is going to be multiplied times, well, 4 times 2 is 8x. And then what happened to the y squared? Well, like I said, y is a constant. So y squared is a constant. You square a constant, it's still a constant. So the derivative of any constant is 0. So that's why we just didn't write anything for this one, because that's 0. Okay, so we really have 1/2 times the quantity 4x squared plus y squared to the negative 1/2 times 8x. And then we can simplify this. Remember, if you have a negative exponent, that's the same as 1 over the positive exponent. So if you have a negative 1/2 power, you can move it to the denominator, and that'll make it a positive 1/2 power. So we're actually going to move this this entire thing right here to the denominator, and then it'll become positive 1/2, which is the same as a square root. Okay, and then we can also multiply the 1/2 and the 8x. So the 2 and the 8 cancel out and give us a 4 on the top. So we have 4x on the top. Okay, so that gives us partial f partial x equals, on the top we're going to have 4x, and then on the bottom, if we move this negative 1/2 to the denominator, it becomes positive 1/2, which is the same as the square root of 4x squared plus y squared. So in our denominator, we're going to have the square root of 4x squared plus y squared. Okay? So basically what we did there was a bunch of different rules from Calculus 1, and it's really just the same stuff as Calculus 1. The only difference is you have multiple variables. But you treat any other variable from the one that you're taking the derivative of as a constant. Okay, and then so we did partial f partial x. Let's go ahead and do partial f partial y. So for partial f partial y, the process is going to be pretty similar here. Okay, so for partial f partial y, once again your other variable is constant. So in this case, x is going to be constant. X is a constant. Okay, and we're going to once again use the chain rule. So using this form here where it's written as a 1/2 power, we're going to once again bring the 1/2 out front and decrease the exponent by 1. So that's the chain rule. Okay, so we're going to have, just like with the last part, we're going to have 1/2 times a quantity, 4x squared plus y squared, quantity to the negative 1/2. And then, so that was the derivative of the outer function. And then using the chain rule, now we have to multiply that times the derivative of the inner function. So the derivative of 4x squared plus y squared, well this time, x is constant. So that means 4x squared is constant. This is constant right here. And the derivative of any constant is 0. So that 4x squared is just going to go away. So really we're just taking the derivative of y squared. Okay? And we're going to use the power rule there. So we bring the 2 out front. So we end up with multiplying by 2y, since the derivative of y squared is 2y. Okay, and then we can simplify this a little bit. Just like with the last part, the 2's cancel out here. So we're left with a y on the top. And then we can move this entire negative 1/2 power to the denominator, and then it's going to become a square root in the denominator. Okay, so after we do all that, we should be left with a y on the top, and then on the bottom, we should have the square root of 4x squared plus y squared. Okay, so y on the top, and then we moved the negative 1/2 downstairs, so it became a positive 1/2. And that right there is partial f partial y. Okay, so that problem was a bit more involved. And many of you may need to review your Calculus 1 to be able to do these properly. I can't do all the different cases, but I'm going to try to do as many of them as I can in this video. So hopefully you'll get most of the cases down. All right, cool. So let's do another example. So far we've seen the chain rule, and we've also seen the power rule, and also how to deal with the square root of numbers, that kind of thing. So for our next example, we're going to actually be doing the quotient rule, which a lot of people hate. I always hated the quotient rule too, but we do need to be able to do it on a couple of problems. So new example, find partial h, partial x, and partial h, partial y. Okay, find partial h, partial x, and partial h, partial y. And for this one, our function is h of x comma y equals 3x plus 4y all over 6xy minus 7. (3x plus 4y all over 6xy minus 7). So this one's harder because it's actually a quotient. Quotient means you're dividing, and so probably the easiest way to do this is the quotient rule. It's easy to forget the quotient rule though, so don't forget you have Google to remind you about that. So for the quotient rule, let's just start with partial h, partial x. So for partial h, partial x, we know that the other variable is constant, so that means y is constant. Okay, and so every single y you see there is to be treated as a constant, but it still has an x on the top and an x on the bottom, so we're going to have to use the quotient rule. So how does the quotient rule go? Well, like I said, if you don't remember something from Calculus 1, you can always go to Google or whatever search engine you use, so you can just type in quotient rule to look it up. So let's see. Oh, this is a complicated looking one. Maybe just look under images. Here's an easy one. So the derivative of f over g is equal to f prime g minus f g prime all over g squared. So basically you're taking the derivative of the top times the bottom minus the top times the derivative of the bottom, and then you divide by the denominator squared. Okay? So quotient rule. Quotient rule. The way most people write it is with u and v. So it says that the derivative of u over v is equal to the derivative of the top, u prime, times the bottom, v, minus the top, u, times the derivative of the bottom, so that's v prime, all over v squared. So it's all over the bottom squared. And you can see that's the same thing as this right here. They're just using f and g. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, so here we want to label everything. Here the numerator is going to be our u. This is our u. And then the denominator is going to be v. Alright, and then we want to just go ahead and calculate u prime and v prime so that we can plug them in here. Alright, so u prime, remember here y is constant, so for the derivative of 3x plus 4y, the 4y is going to be constant, so the derivative of that is 0. And then the derivative of 3x is just going to be 3. Okay, so here u prime equals 3. Okay, and then for the derivative of v, for v prime, again we're treating y as a constant. So we're just taking the derivative with respect to x. So this x is going to go away, and we're going to end up with 6y. Okay, so v prime equals 6y. And remember the derivative of negative 7, because negative 7 is a constant, is 0. Right, so we just end up with v prime equals 6y. Okay, so now we have our u, we have our v, we have our u prime and our v prime. So now we're ready to plug everything in to the quotient rule. So partial h, partial x is going to be u prime v. So that's going to be 3 times the quantity 6xy minus 7 minus uv prime, so that's going to be minus the quantity 3x plus 4y times 6y, because v prime is 6y. And then this is all over v squared. So that's going to be all over 6xy minus 7 quantity squared. Okay? And it's a lot to write down, and there's a lot of little variables here and there, but just make sure you check your work, because otherwise it's easy to make a little mistake. Particularly on the test, you want to check your work. Okay, but we can simplify this a little bit. We can distribute the 3 and distribute the 6y. Okay, so we're going to distribute the 3 over here and distribute the 6y over there on the top. So what's that going to give us? Well, on the top we're going to have 3 times 6xy is 18xy minus 3 times 7 is 21. And then distributing the minus 6y, remember we have to distribute the minus as well as the 6y. We're going to get negative 6y times 3x is going to be negative 18xy. And then we're going to have minus 6 times 4 is 24y squared. So we're going to have a minus 24y squared. And then this is all over v squared. So this is all over 6xy minus 7 quantity squared. Okay, and then in the numerator, we can actually combine like terms. So we notice that we have an 18xy and a negative 18xy, so those just cancel out. And then we're left with a negative 21 minus 24y squared. And that's actually how they leave their answer. Okay, so this is going to be our partial h, partial x. So our partial h, partial x is going to equal negative 21 minus 24y squared all over the quantity 6xy minus 7 quantity squared. So there is partial h, partial x. So that's a lot of work. But there's not a ton of the quotient rule problems on your homework. Just maybe 1 or 2 of them. Okay, and then we're going to go ahead and do partial h, partial y, which is going to be pretty similar. We're still going to be using the quotient rule. It's just for partial h, partial y, now our other variable is going to be constant. So this time, x is going to be constant. Okay? X is going to be constant. But we're still going to be using the quotient rule. It's just our u prime and our v prime are going to be different. So let's redo our u prime and our v prime, because now we're actually treating a different variable as a constant. We're treating x as a constant. In fact, let me do this in blue so it doesn't look so confusing. So we're going to do this work in blue for partial h, partial y. Okay? So for partial h, partial y, we still have the same u and we still have the same v. So u is the top, v is the bottom. And then our u prime is going to look different from last time. So last time y was constant, but this time x is constant. So since x is constant, that means 3x is constant, and the derivative of 3x is 0. So we're just going to be taking the derivative of 4y, which is going to be 4. Okay, so here u prime equals 4. Okay? And then for our denominator v, for our v prime, once again, x is going to be constant. So treating x as a constant, we take the derivative of 6xy. So the y is going to go away, so we're just going to be left with the 6x. Okay, so our v prime equals 6x. Okay, so u prime is 4 because x is a constant, and v prime is 6x because, once again, x is a constant, so 6x is a constant. All right. So we got our u prime and our v prime. So now we're ready to use the quotient rule again. Okay, so plugging in partial h, partial y is going to be u prime v. So that's going to be 4 times 6xy minus 7. 4 times 6xy minus 7. That's our u prime v. And then our u v prime is going to be 3x plus 4y. Okay, so we're going to have minus 3x plus 4y. So that's our u times v prime, so that's going to be times 6x. Okay, so once again, that was using the quotient rule. If I did that right, that should be u prime v minus u v prime. U prime v, so let me just check that. 4 times 6xy minus 7, that's u prime v, minus u v prime. So that's minus 3x plus 4y times 6x. Okay, and then this is all over v squared. Okay, so this is going to be all over v squared. But here we have the same v as we had in the last one. So that's still going to be 6xy minus 7 quantity squared. So that's all over 6xy minus 7 quantity squared. And then just like with the last problem, just like with the last derivative that we did, we want to distribute the 4 and the negative 6x. So we're going to go ahead and do that. So up here we're going to distribute the 4 and then the negative 6x. Okay, so after we do that, let's see what we have left. Well, on the top left, 4 times 6 is 24xy, minus 4 times 7 is 28. So you should have 24xy minus 28. And then distributing the minus 6x on the top right, we're going to have negative 6x times 3x is negative 18x squared. Minus 6 times 4 is 24xy. Okay? So we have 24xy minus 28 minus 18x squared minus 24xy. And then this is all over v squared, so this is all over 6xy minus 7 quantity squared. Okay? And then we can go ahead and combine like terms on the top. So combining like terms here, we've got the 24xy and the negative 24xy, those cancel. And then that leaves us with our final answer. So our partial h partial y is going to be partial h partial y equals negative 28 minus 18x squared all over the quantity 6xy minus 7 quantity squared. Okay? And that's our answer. And that's how my math lab writes their answer too, so we're good there. And obviously the quotient rule is tough. It's annoying because it has so many little parts. But you know, it is what it is. A lot of people don't like it, but we still have to do it. So, but you know, it wouldn't be calculus if we didn't have these harder problems. So let's see another example. This one is going to be using another rule from Calculus 1, which is the product rule. And we're also going to be dealing with natural log and e. Okay, so a new example. Find partial f, partial x, and partial f, partial y. Okay, and this time our f of x comma y is actually equal to e to the xy times ln of 3y. E to the xy times ln of 3y. So we don't have any quotients here, we're not dividing, but we do have a couple of products. So we're going to have to end up using the product rule, at least on one of them. Alright, so let's start with partial f, partial x. So for partial f, partial x, your other variables are constant. So here y is constant. Okay. So our partial f, partial x, we're treating y as a constant, which actually means, believe it or not, the ln of 3y, because y is a constant and 3 is a constant, ln of 3y, that entire factor there is constant. Okay, so that's constant. And then also, this y up here is constant. Okay, so both of those are constant. So the partial f, partial x is actually pretty easy to calculate. So we just leave the ln of 3y there because it's a constant, and we take the derivative of e to the xy, treating y as a constant. But we do have to use the chain rule. So remember that the derivative of e to any power is just e to that power. Okay? So the derivative of e to the x is e to the x, so the derivative of e to the u is still e to the u. So here we're just going to have an e to the xy, because the derivative of e to the xy is still e to the xy. But we have to use the chain rule, so we have to multiply this times the derivative of the inner function. So here the inner function is xy, okay? and y is constant, so we're really going to be taking the derivative of x. So we're going to be multiplying times y. Okay, so that's the chain rule. We're doing the chain rule there. Okay, so the outer function is e to the xy, and the inner function is xy. So we took the derivative of the outer function. Well, the derivative of e to any power is just e to that power. And then we multiplied that times the derivative of the inner function. So the derivative of xy, where y is constant, is just y. And then we still have our ln of 3y here. Okay? We still have our ln of 3y. And because y is constant, ln of 3y is constant, which means we don't have to take the derivative of that. Okay? And then to write our answer the way they do in my math lab, we're going to be actually writing it with the y first, and then the e to the xy, and then the ln of 3y last. Okay? So our answer is going to be y e to the xy times ln of 3y. Okay? Y e to the xy times ln of 3y. Okay. So that was actually the easy one. I know there's a lot going on here, but the reason that one was easy is we didn't end up having to use the product rule. Okay. All right, so this is going to be our partial f, partial x, right there. Partial f, partial x. Okay, now the more challenging one is the partial f, partial y. So let's do that one. So for partial f, partial y, our other variable is going to be a constant. So here x is going to be constant. And we're taking the derivative with respect to y. But this is going to be more challenging because both of these factors involve y. So what we're going to be using here is, since we have something multiplied times something else, we're going to be using the product rule along with the chain rule. Okay, so how does the product rule go? Well, most people are able to remember that. Most people don't have to look it up on Google. So the product rule says that the derivative of two things multiplied together, uv prime equals u prime v plus uv prime. Okay? And the order in which they write it might be a little different. You could write uv prime plus u prime v. It doesn't really matter which order you write it in. Okay, that's the product rule. So here, the function we're dealing with, since both of these factors involve y, and y is not a constant this time, we're going to have to use the product rule. We just have to. Okay, so let me actually do that in a different color. I'm going to do that in blue now. Oops, that's not blue. Okay, so we're going to be using the product rule here. This is our u. E to the xy is u. And then ln of 3y is v. So this time, because y isn't a constant, we actually have to use the product rule. Okay, so since our u is e to the xy, that means our u prime is going to be the derivative of e to the xy. Now the derivative of e to the xy is e to the xy. So we have e to the xy, but then we have to multiply that times the derivative of the inner function. And the inner function is xy, okay? And we know that x is actually a constant. X is a constant. So the derivative of xy is actually going to be x. Okay, so we have e to the xy times x. So that was the chain rule, the derivative of the outer function, which was e to the xy, times the derivative of the inner function, which was xy, and the derivative of xy, where x is a constant, is just going to be x. Okay? It's a little bit tricky. So there's our u prime. And then our v prime is a lot easier. Well, hopefully it's easier for you. But again, it's a composite function. So first of all, what's the derivative of ln? Remember that the derivative of ln is 1 over. So we're going to have 1 over 3y. Okay? That's the derivative of the outer function, ln. And then we multiply this times the derivative of the inner function, which is 3y. And remember here, x is constant, but y is not. So that's why we're taking the derivative. So the derivative of 3y is actually 3. So we have 1 over 3y times 3. Okay, but the 3's cancel out. So that means our v prime is actually going to equal 1 over y. Okay? So it's a bit of work, but we got our v prime. So now we're ready to plug everything into the product rule. Okay, so for the product rule, partial f partial y is going to equal u prime v plus u v prime. So that's going to be, u prime is going to be x e to the xy, x e to the xy times v, which is ln of 3y, so there's our u prime v that I just wrote there, u prime v, and then we have plus uv prime. So in this problem, u is e to the xy. That's going to be e to the xy times our v prime, we said, was 1 over y. Okay, so it's e to the xy times 1 over y. So that right there is our u v prime. And I think I might be writing the product rule in the reverse order of which most people write it, but it doesn't matter because you're adding. Okay, so anyway, if I switch the order around, that's how they would, I think that's how most people write it. I don't know why I did it backwards, but it doesn't matter. So if I switch the order around, that's the order they write it in my math lab. So what are we going to have here? We're actually going to have switching the order around, we're going to have e to the xy over y plus x e to the xy times ln of 3y. Okay, so I went ahead and switched the order around. I think I did my product rule a little bit backwards from the way most people do it. But that's fine because you're adding. You can always switch the order around. Okay, and then that's our partial f partial y. Okay, so partial f partial y is e to the xy over y plus x e to the xy times ln of 3y. It's pretty challenging. But that's why I'm spending a lot of time on this, doing a lot of examples. Okay, so I wanted to do a few more. These are definitely tricky, so I wanted you to see all the little tricks that we do for the different kinds of problems. Okay, so new example. Find partial f partial x and partial f partial y, or del f del x and del f del y. And for this one, our function is going to be f of x comma y equals sine to the 8th power of 3x minus 3y. Okay, sine to the 8th power of the quantity 3x minus 3y. So this one's a little bit challenging because we have a pretty big composite function. And what it really means, the sine to the 8th power actually means sine of the quantity 3x minus 3y, quantity to the 8th power. So just in case you weren't sure what it meant, that's what it actually means. Okay? So this sine to the 8th, you can actually bring the 8th power out front like that, and then hopefully it'll make it easier for you to use a chain rule. So let's start with our partial f, partial x. Okay? Partial f, partial x. So for partial f, partial x, we're treating the other variable as a constant. So y is going to be a constant. Okay? And then we actually have two composite functions. So there's three functions in one, is what I'm trying to say. So we're going to have to use the chain rule twice. Okay. So we're going to use the chain rule twice. And you work your way from the outside inward. So that's why it's called the outer inner rule, because you start on the outside and you take the derivative and you work your way inward. So here the outermost function is the 8th power. So we're going to first take the derivative of the 8th power, which means we're going to bring the 8 out front and decrease the exponent by 1. Okay, so we're going to have 8 times a quantity, sine of 3x minus 3y, quantity to the 7th power. So all I did there was I took the derivative of the outermost function, and I leave the inner functions alone. And now I work on, now I will go ahead and work on the middle function. So I just took the derivative of the outer function, and now I'm going to take the derivative of the middle function. So here the middle function is actually sine. And we know that the derivative of sine is positive cosine. So now we're going to have positive cosine of 3x minus 3y. So when I say you use the chain rule twice, I mean that you work from the outside inward. Okay? So work from outside inward. Okay? Taking the derivative of each function. Alright? So when you're doing the chain rule, it's called the outer inner rule because first you take the derivative of the outer function, inner left alone, and then you multiply that times the derivative of the inner function. So here, because we have three functions in one, we started with our outermost function, which was the 8th power, took the derivative of that, we left the inner one alone, and then we multiply that times the derivative of the middle function. Okay, and here our middle function was sine, so the derivative of that is cosine of 3x minus 3y. And then our innermost function is actually 3x minus 3y, so we still have to multiply times the derivative of that. So that's the last part of the chain rule. So what's the derivative of 3x minus 3y? Well, because y is constant, negative 3y is constant, so it's just going to actually be 3. So we're going to have times 3 at the end here. So I know that's a lot of stuff going on, but it's really stuff from Calculus 1. So if you don't remember Calculus 1, you're going to have to review that. But anyway, we can kind of multiply the 3 and the 8, but then other than that, there's not really anything else to simplify. Okay, so for our partial f partial x, if we multiply the 3 and the 8, and then we go ahead and bring this 7th power back here on the inside, then the way that you write your answer on my math lab is going to be 8 times 3 is 24. Okay, so our partial f partial x is going to be 24 sine to the 7th of 3x minus 3y. 24 sine to the 7th of 3x minus 3y times cosine of 3x minus 3y. Times cosine of 3x minus 3y. Okay, so there's our partial f partial x. And that's how you want to write your answer at the end. Okay? All right, and then the only good news is partial f partial y is going to be almost identical. It's just at the end, we're going to be taking the derivative with the other variable being constant. So this time y was constant for partial f partial x. So if we do partial f partial y, partial f partial y, this time x is going to be constant. Okay? But most of the rest of the problem is going to be the same in that we work our way inward from the outside. Okay, so if we take it in this form that I wrote here in red, and we work from the outside inward, taking the derivative of each function, that's the chain rule. So let's start by taking the derivative of the 8th power. So we're going to bring that out front and becomes the 7th power. So we're going to have, once again, 8 times a quantity sine of, it was 3x minus 3y, quantity to the 7th power. So all I did in that step was I took the derivative of the outermost function using the power rule, and now I'm going to multiply this times the derivative of the middle function. So the middle function is sine, and the derivative of sine is positive cosine. So for our middle function, we're going to have cosine of 3x minus 3y. All right, and then we finally multiply that times the derivative of the inner function. So the inner function is 3x minus 3y. And for 3x minus 3y, x is constant this time. So the derivative of 3x is going to be 0. And then the derivative of negative 3y is going to be negative 3. So we multiply at the end by negative 3. Okay, so after we do all that, we can just rewrite our answer the way we did the last one. So we're going to go ahead and bring this 7th power in here and multiply the 8 and the negative 3. So we actually get negative 24 times sine to the 7th power of 3x minus 3y times cosine of 3x minus 3y. Okay? And then this here is how you want to write your final answer. So that right there is your partial f partial y. Partial f partial y. Okay, so negative 24 sine to the 7th of 3x minus 3y times cosine of 3x minus 3y.